This is 2.5 continued, where we are actually solving compound inequalities. So to solve a compound inequality, you can solve the two compound inequalities separately, or if you have it written as an and it's written in as one long compound inequality, as a single inequality, you can solve it by performing the same operation to each expression that you have. So if we have -1 is less than x plus 4 is less than 7, I want to get x by itself. And x is going to stay in this middle portion. It's not going to move. So to get x by itself, I'll subtract 4. And what you do to one expression, you have to do to all of them. So left, middle, and right. And then we get -5 is less than x, which is less than 3. And if I were to graph that, I would have -5 and 3, and my graph would be in the middle part here. If we have 5y minus 2 is less than 13, or 4y plus 3 is greater than 27. I'm going to solve each of these separately. We are not going to write it as one long inequality because it is an or. So I would add 2 to each side to get y by itself. Then to get y completely by itself, I'm going to divide each side by 5. On the right, I would subtract 3 on each side and then divide each side by 4 to get my answer of y is less than 3 or y is greater than 6. And y is less than 3 points to the left, y is greater than 6 points to the right. Now if we have 2 is less than 2x plus 6 and 2x plus 6 is less than 18, I have this same expression in each one. So I can put that in the middle and have my 2 is less than that, and that is less than 18. So if I rewrite it in the middle, now if I'm working to get x by itself, I'm going to subtract 6 from everything. Then to get x completely by itself, I'm going to divide everything by 2. To get -2 is less than x, which is less than 6. I could choose to keep them separate and then combine them at the end, and I'll get the same answer. So we can combine it here because we have the same expression. If we have different expressions, you have to solve them separately until you get something the same. Then you can combine them. Only for an and. Alright. This one says, a bike shop rents bikes with heights ranging from 18 inches to 26 inches. They say the height should be 0.6 times the cyclist's leg length. Write and solve an inequality that represents the lengths of legs the bike shop can provide for. So if 18 is on the small side, 26 is on the tall side, and we have the leg lengths in the middle. And this would be 0.6 times their leg length. Well, the height of the bike, 0.6x, represents the height of the bike compared to their leg length. So x is leg length. To get x by itself, we divide each by 0.6, and we would get 30 is less than or equal to x, which is less than or equal to 43.3. So the leg lengths can range from 30 inches to 43.3.